Again with the microphone on. Ernie said that was the Police, and we just changed songs sort of midstream there. What was the last one we were listening to? What? King of Pain. I take personal exception to that in a math class as a start. You have a smug look in your face at this point. This is pleasant stuff we're doing, not painful. And I'm not selling that very well. We are looking at credit cards and interest and solving problems with interest. That's what 8.6 is about. I spent, of course, quite a bit of time in Math 10 on simple interest. And we had a unit there in which we calculated the amount of money we would have in a payoff table. We kept it pretty straightforward. We said, you're not going to charge anything. You made one charge, self-discipline. So we did things like you had $1,000 that you had charged, and we said you just leave your credit card alone, and we tried to pay it off within a year's time. We went ahead, and in doing that problem, made an agreement that we would do a minimum payment of 10%. So if I look at that, and we're just going to go to the board here for a minute and look at this idea that we carried through. I asked you to spend some time last night on the simple interest unit. So as I go to the board, we talked about an 18%. We called it an APR, and that stood for annual percentage rate. And we went ahead and we said if you owed $1,000 on that credit card, then the idea of getting the interest was very simple. You multiplied 1,000. You multiplied it by a 0.18, and technically it was times 1/12 of the year, and we just calculated simple interest for that period of time. And we said that that would be the interest you would add to your credit card, and so your bill was your original 1,000 plus this interest. So this figure, when we did it with the calculator, just reminding you of that, and I didn't use the percent key in the calculator to do this. We just did this sequence, and that came out $15. So we argued that you would then owe your 1,000 plus $15, and so at the end of that first month you'd be billed $1,015. Yes? We will be using the calculator on this particular portion, yes. On 8.6. No, you would have great trouble in this doing it in your head. So we will be using a calculator in this part. One of those rare exceptions. And I do have a box full of calculators here that we'll be using. The point being, you now make a payment. And the payment we said was a 10% minimum payment. And so that meant you were going to pay 101.5. So you had a payment then, 10%, and so that was a 101.5. Of course, you subtracted that from your bill. So this right here was the billed amount, and you subtract off the payment, and then you get your new balance, and you just keep going through this. Now, the thing that you learned in this approach was at the end of 1 year, you still owe some money. So you haven't paid it off. And of course, the reality here is the discipline not to charge to your account is a tough one. So in this process, when I have 101.50 and I then subtract, so I do the subtraction, I'll get the new balance, and we just carry this on. And then we compared this to paying like 101.50 every month. And then, of course, that gave you a zero balance at about October. So you had 2 months with nothing on the card. Now, this oversimplifies the situation to a degree, because if you look at the various ways credit card companies can charge interest, there are a host of things that we aren't bringing in to bear on this. One, they may have, based on your credit rating and your debt to income ratio, they may moderate the advertised APR to a figure that's different because of your pay schedule, otherwise how you pay your payments, how much you owe. So this is not looking at it in as detailed as we might. So one of the things in terms of what we're doing in the Math 20, we go into a little more depth. So I decided to spend some time last night and this morning when I wasn't grading to just see what things are being done. And one of those things where you find yourself quickly into more information nearly than you wanted, nearly information overload. But one of the things that, as I was trying to find sources of information, surprisingly, I thought what was done in Wikipedia was about as good as anything I've read recently, and I encourage you to go to that. Now, what I've done, because I didn't want to have to get out of the course compass that I was working on before we started, and I have changed the due dates for 8.2 and 8.3 as have been requested to a later date. But I went ahead and put a portion of what was available on the BlackBerry. And so I'm going to come back center here for a moment. I'm going to bring up that screen. And this is using the document cam with a BlackBerry to give about as good a readability, better than what I can do on the computer. But this was the interest rates part, and this was relative to the United States, I thought a very interesting figure, 7 to 36%, and depending on the bank's risk and evaluation and so on. And so I've made a comment to you if you miss a payment, and the banks are much less generous than they were, say, 3 years ago. They're being very picky about how often you pay off your bill, and they're very picky about raising the rate, where if you had an 18%, you may be at 24, 26, 28%, depending on what else is going on. So this 18% was a kind of generalization. It's very typical. 19.6 is often the case on new accounts. And your amount of money you can charge, I guess, say a limit is often in a new account very low, maybe $500, $1,000. And if you have pretty good credit ratings, you can get $5,000, $10,000 as your limits. And if you have a business, your limits can go up even higher than that. And there are interest rates, everything from 0% on credit card transfers from another account to your new account. But then if you charge on that new account, even though you have 0% on the transfer balance, you may be paying more than 0% because they charge you the highest rated interest first. So if you pay off your bill and you still haven't paid it off, you aren't getting 0. You're paying on the higher rate of interest for something you've charged. So my point being, there's a lot more going on here. But I was interested in things like, for example, if you used your credit card in Europe, you paid a higher interest rate than you would using it in the United States for certain credit cards. And so as I looked at this result on Wikipedia, there was an interesting contrast here. I'm going to bring it down. Not yet, Ernie, but we'll get in there. The contrast here was in South America with Brazil. And I thought this was rather interesting as we cut to here, that in Brazil, okay, 50% of over that, let's see, Brazil has much higher interest rates, about 50% over that of most developing countries, which average, and this was surprising to me, 200%. Let that sit in for a moment. And so they're as high for Visa and MasterCard, an annual interest rate as high as 240%. And they cite The Economist at a particular time, coming off there, Ernie. So we have as high as 240%. Now think of 18 versus 240, and we worry about going up to 24% or 26%. And in Brazil, they're going to run 240%. Well, it's interesting, as brought up in this, the actual credit card that we have, we don't have much of a grace period any longer. So if you have a bill due the 10th of the month and you're in the 11th, you're late, no grace period, and your interest rate jumps up. Well, evidently in Brazil, at least at the time this reference was made, which is within the last couple of years, you had a grace period. So maybe it was due the 10th and you'd have 10-day grace period, and if you pay it off within that point, you don't pay any interest. And so they talk about liquidity, and of course that's been the big issue in the United States for banks. When they had defaults on their loans that they were carrying, they didn't have money to pay out if somebody says, I want to withdraw the money from the bank. So to get liquidity, you want to be able to get money available to you very quickly. So if you have this credit card in Brazil, the idea is you can charge, and by the way, the limits are like $400. So the point is I can get $400 really fast and have it to pay off something that's due, like a rent payment or something, and then I have, in essence, provided myself 30 days of money that I don't have to pay interest on, and that gives me liquidity. Then I pay back the credit card, that $400, within the grace period, and things are great. It's when you don't, it's like a loan shark saying, yeah, I'll loan you money, it's 240%, it's due tomorrow, but if you don't pay it back tomorrow, we'll break 2 legs and 1 arm. Much the same idea, and so we have liquidity as what's an advantage there. Now, one of the things that's brought up is how do you compare interest rates, and there's a new term that isn't in our book. We've talked about the APR, and what I'm going to do is bring this up again, and I'm going to scroll down, so Ernie, give me a moment. And I'm going to bring you to something called an EAR. Now, this goes under the category of calculation of interest rates as we go to the document cam. And most U.S. credit cards, and I agree with this, are quoted in terms of a nominal APR, which is referred to as an annual percentage rate. Now, if we come off there for a moment, this was done, I believe, in 1968 by Regulation Z by the federal government, where they were worried about not being able to compare what kind of interest you were getting. Basically, the loan shark companies, which were saying, well, you know, your interest is only 5% per day. That sounds pretty good until you look at it as a yearly rate, in which it's outrageous and immoral. And so the government said we're going to have some way of comparing. So we have the APR, the annual percentage rate. And there's another one called an EAR, which is the effective annual rate. And so what I'm going to do is bring this up again. And you'll note here at the bottom of it says the EAR. And despite the APR, it is not necessarily, and let's come off there for a moment, I'm going to have to scroll down, says the more effective rate, the more direct reference for the 1-year rate is an EAR, and here's how it's calculated. So you take your annual rate, divide it by the number of times you compound. So if we were going to do it 12 times a year, compound monthly, you'd have 1 plus your APR over 12, and then you take it to the 12th power and subtract 1. Okay, so coming off there, if we take this 18% that we have as this APR, it's saying you're going to take your 18%, you're going to divide it by the 12, and then you're going to take that to the 12th power and subtract 1. So in essence, if you look at what we would be doing here, just with this part by itself, you've done this before. We used the y to the x key. So let me illustrate from what I said yesterday, that when we talk about the y to the x key, we said if we were going to compound quarterly. So if you had the same interest rate, and my goodness, you don't get 18% in a money market account. Okay, you might get 3% or 4% in a money market account. But we would take that 18% and divide by 4, because you get it for the 3 months. And so you multiply this by what? By your balance, your principal, to get how much you would have in a bank account or a money market account at the end of that first quarter. So if you were doing it for the year, you would raise this to the fourth power and simply multiply by the 1,000 you've invested. So that's how we use the y to the x key. So at this point, I don't know if we have calculators. Jessica, could you help out here and just hand out calculators for anybody who doesn't have that one? Yeah, that one right there. This is the EL531 we're going to reference. But the point is, this would give you the money in a money market account at the end of 1 year compounded 4 times quarterly. So let's get those calculators out and let's do that. So what you're going to do is get me the 1 plus 0.18 over 4. That's going to be your y key. This is going to be your x key here. And we're going to see how much money we would have. And this is just what we call compounding on a monthly basis. So turn the calculator on, take your 0.18, divide it by 4, add 1 equals, so if you need the sequence, 0.18 divided by 4. Usually I hit an equal sign here, and then I just hit plus 1 equals. And so that's going to give me the y value. And what do you get here? 0.445, correct? Then you're going to take that, so coming up to here, you'll hit the y to the x key, and then we're going to hit the 4. That's taking that to the fourth power and equals. And what do you get there, just so we can have that? 1.1925. Okay, there's more garbage to come. Okay, let me, what was it, Sandra, after the 5? 18601. And of course, this decimal can keep going forever if it is an irrational number. And the point being, we then multiply that by what? The $1,000. And so the argument is, at that point, I'm going to have $1,192.51. Now, I came across another statement that was intriguing. My argument has been that, generally speaking, a bank is not going to give you rounding up on their interest rate, or on their interest they give. But if you are paying interest, then they round up. I'm going to come to that problem because I hit a new wrinkle as I was reading in the research I was doing, in which the banks in one case do have to round up in your favor. Otherwise, the APR that they're actually charging is higher than the one they report, and they would be then in violation of federal law, which is an interesting wrinkle. Now, we said that one of the things when we went for the 1% interest increase in our state tax, that the business had the option of charging you the penny, rounding up, or paying it out of their own pocket. So they charge you and then they pay the government through your largesse, through your generosity, what the state's asking. So again, the round up, round down has an interesting little point, whether or not a bank and a credit card is in essence charging you more than what they advertise on the APR. They're not allowed to do that by federal law. So the point being, this you're familiar with. Now, if you look at this figure we just did, let's come back over here now, sliding just a little bit to the left. Thank you, Ernie. When I got this 1 plus 0.18 over 4 and then took it to the fourth power, then I got this number. If I subtract off a 1 from this, I am doing what's called the EAR, the effective annual rate, which is at 19.25%. Okay? So that's a different idea, an EAR, an effective annual rate. Well, you may say, well, wait a minute. This was for money market. You put money in the bank and you leave it there, you're getting interest on it. What's that have to do with a credit card payment? Well, if I come back now, Ernie, and maybe we can go camera 1 for the moment on the left side of the board so we aren't panning back and forth, if you would. So just camera 1 on the left side where I have the 18% APR with about this, thank you. Now, if I come back, no, the APR here, we're still panning. Okay, coming to here. My point was that we found, in essence, a simple interest. We just said it's PRT. The formula for simple interest, I'll remind you, the principal multiplied by the rate multiplied by the time, and that is T in years. That's where the 1/12 came from. So when I did this down here, I'm using that formula to get my interest. So I'm looking at the time as 1/12 of the year. Well, that's not the only way banks have a choice of charging you the interest on your balance. Now, just to add in another comment here, and Ernie, could we pick up a little bit of that arrow? Just slide over a little bit to the left. I want people to realize it. Okay, this comes down into here. Now, I made the caveat here, you aren't going to put any more money onto this account. In reality, you do, correct? So the question is, what are they going to charge you? On what balance? And so, related to this simplistic, simple interest calculation, they actually take your average daily balance. So they just look at 30 different days of your balance each day for what you've charged. And they take the average of that and then multiply by this. So that's one wrinkle we hadn't talked about. But another wrinkle is to, instead of charging you simple interest, charge you compound interest for the 30 days. Because that's what they're giving up, they argue. Because they do what? On a savings account you have in the bank, they aren't doing quarterly compounding. They give you continuous interest, in essence. That's where we used the e to the x key yesterday. Well, the daily is darn close to what you get with continuous compounding. And so one of the choices they can make, and now, Ernie, we're going to go to camera 2 with the space I have over here on the right. If I go over there with the same idea I did here, but instead of doing it quarterly, like I did right here, we could look at it daily with the same argument. Now, remember here we said 1 plus 0.18 over 4 to the 4th power. Well, what happens if I did it daily for 30 days? So I'm going to get my compound interest like it was a savings account, but this is on my credit card account. This changes the wrinkle a little bit. So I'm going to have 1 plus 0.18, and the banks agree to do 365 days in this calculation. So I'm going to take 1 plus 0.18 divided by 365 and then raise it to, okay, how many compounding periods do I have? Well, I have 30 compounding periods out of the 365 for the year. So if you look at it, it's 30 over 365 times 365. So here's what I'm going to have as I come over here. We're going to take the $1,000, just like we did for compound interest for a money market, but we're going to take it at 1 plus 0.18 over 365 because I'm compounding daily. And for the year, I'd be doing it what? 365 times. Now that becomes important because that's going to give me my EAR when I do that and subtract 1. So just a reminder that the EAR is going to be this 1 plus 0.18 over 365 to the 365th power minus 1. We're going to get that in a moment. But this is times 30 over 365 because I'm only doing it for 30 days. We got it? Just like what I did before. But see, when we did this for, okay, I'm going to have to slide just a little bit, Ernie, back to here. When we did this problem, this was just for 1 year, correct? 4 times a year for 1 year. If I'd done this for 10 years, then that's the kind of problem we did in Math 10. we would say 40 up here because you have 40 years involved. If you did it for 20 years, you'd have an 80 up here. Well, for your credit card, you're only doing it for what? A fraction of the year, not a number of years. So that's the wrinkle. So let's come back to here now. So what I need is, in essence, to have this set up. 0.18 divided by 365 equals plus 1 equals, and then I'm going to bring that up and say that I want you to take that y to the x, then I want you to hit 3, and equals. And then we're going to multiply that by our 1,000. Okay, are we ready? Can you do that for me? 0.18 divided by 365 equals, add the 1 equals. That's that mess in the parentheses. Then the 365 times 30 over 365 is just 30. You're compounding 30 times for a 30-day month. And then, by the way, if this was 28 days, then it would be in February 28. If it were in October, it would be 31, and so on. So in April, this month, we just do 30. Get your number, multiply by 1,000, and what do you get? So my interest I got charged here was $14.90 because it was only a 30-day month, and it was based on a 365-day year. Was it to your advantage? Yeah, what did we pay the first method? Camera 1, Ernie. I'm assuming you're still there. Good. We paid $15. We gained 10 cents. You're not excited about that dime. In our economy, where what will a dime buy? Won't even buy money in a parking meter, or will it? Most of them are 25 cents now. So dime. What can you buy for a dime? Gum. One stick of gum, right? Okay, so not a whole lot, but you gained a little bit. Now let's go back to camera 2. Now we didn't take a number in between I wanted to get here. Let's find the EAR. What is the EAR? I feel like I'm talking about the DAR, Daughters of the American Revolution, but this is an EAR, an effective annual rate. So I want 0.18 over 365, add 1, take it to the 365th power, and subtract 1. In essence, you follow this. Let's go through it. 0.18 divided by 365 equals, add 1 equals your y to the x key, then 365 equals, and subtract 1. What is my effective rate? Yeah. The effective rate is like a 24.97 interest rate. You have what? After the 24. Like that? You don't agree with the 24%. Okay, so you're getting what instead? 19764. Okay, etc. We agree in the 1976. The next two numbers. 4243, I'll round off. I am getting different answers from different people. So we agree in this much. I'll stop with that agreement. I feel good. Okay, so we're saying an EAR of 19.7% instead of 18. Now, I didn't get upset over the idea of a 24, and let me show you why. I thought that was not a necessarily unreasonable answer. Ernie, now with camera 1, can you bring it back into where I'll be center, because I'm going to come back to the BlackBerry, and I'm going to look at some of the EARs that were calculated for interest rates. So hopefully you're about to the point you can bring me in, and we'll make that transition. Okay, now what I'm going to do, don't come to the BlackBerry yet. I need to bring this down. Okay. At this point, it says the EAR for compounding daily, well, this is not nice. I'm getting that kind of mess out of it, is always, let's see, the EAR for compounding monthly is always less than the EAR for compounding daily. And, of course, that was the 18 versus the 19. However, the relationship of the two in billing periods depends on the APR and the number of days in the billing cycle. So, for example, they used an APR at 12.9%, but came up with an effective rate. Let's see what we have here. They aren't showing, okay, daily compounding, and I was going to see if they gave us numbers there that we could compare. Okay, let's come off there for a moment, Ernie, while I do some searching, so that you aren't having to watch. Okay. There we go. A high U.S. APR of 29%. Now remember, that's nearly 30. That's the kind of interest if you've missed payments and you're in deep water. An effective rate of nearly 35%. And if we look at, for monthly compounding, it's a little bit less at 34.48%, so about a 0.5% difference. And so my argument here is the higher your interest rate for an APR, the higher the EAR. And so a nearly 30 jumps to 35%. I was not surprised when you said that this 18 went to a 24 instead of the 0.19. So interest rates can be calculated in this fashion. Two different approaches. One was the simple interest that we talked about in Math 10, PRT. Here was, in essence, a compound interest on daily compounding, and by the way, this would have been done on the average daily balance. So the question, what interest rate are you really paying? I know in the credit cards I have that they send out that, what they're required by federal law now, where they tell you the rates and all the information. It's 5 pages, small print, fits in an envelope, and it amounts to spelling this all out, what techniques they use. And I've never appreciated quite the complexity of what was available to them until I took time to go further into what we are doing in this section of our book. So what I'd like to do now is look at what's done in the text to put this in focus, if you will. The first point being, we have a definition for principal. Okay, this is something we've talked about before. The initial amount of money. And of course the interest, the money that is a percent of the principal that you either pay or get paid, and the interest rate is used to calculate the interest. The PRT is the formula we use. Coming off there for a moment, Ernie, as I come down, this is the formula we talked about, simple interest. I equals PRT, and that's what we did for the work in the simple interest unit. And of course, the calculations here are very straightforward. It's the kind of thing we've done before, and they use as an example $800 in a savings account getting simple interest in 1 year at 3%. Now, again, coming off there, I think this is not reality because you get interest compounded, either continuously or you get it compounded quarterly. About the only place I know that you get interest, simple interest in this form, is from an uncle. And you say, I want to borrow $800 from you, and I will pay you interest, and the interest is going to be, just hold on to it for a moment, that'll be okay. The interest will be for just the 1 year. So you take 800 times the 3%, and that's what he expects back. And then you hope he's understanding if you didn't pay it back quite in time. You hope within your lifetime that you pay it back. And of course, the final balance. And what did we do to simplify this? We just said you multiply the 800 times 1 plus 0.03 and just do it one time. So this is not very atypical, to do things for a fraction of the year. Simple interest calculation. We've done it with a quarter and just said that's going to be 1/4 of the year for 3 months. But if you look at 3 months as being 90 days, I thought you might find it interesting. That's what's done here. Taking a 15% simple interest, I'm on page now 623, and here is your 3 months instead of as a quarter done on a yearly basis of 365. Now what I don't have is a good answer for you, and I apologize for that. I don't have an answer as to whether that is realistically done by the banks at this point as 1/4 or as we see it here as 90 over 365. And I don't have an answer for you. I think for our calculation purposes, treating it as 1/4 oversimplifies the problem, but if you're going to do it with the calculator, it makes a heck of a lot more sense than doing that as you would with a computer. And none of this gets done with the calculator. It's going to be done with computers and programs in the banks. Now that contrast, where we're talking about in example 3 in page 624, this is where they treat it the way we did, and this has to do with working backwards in a problem, and this is where you have the 3 months out of the 12 for 1/4. This was a case where this is the nosy neighbor, where you know you have $6.80 interest for the quarter, and you're trying to figure out how much principal they had. And it's none of your business. However, called privacy. But you calculate that for your interest, double meaning there, bit of a pun, but it's going to come out right at 500, and notice the approximately equal, the double tilde that's used here to avoid the process of rounding any more than that. This is the formula we've been using. This required for me in Math 10 a lot of explanation to try to get you to understand that when you take the principal and add to it the interest, and then you use the distributive property and pull out the letter P, you get P times 1 plus RT. That took nearly a day in Math 10 to get you comfortable with that, and many didn't. This is called the balance, hence B. Now I call it A sometimes for amount. And we morphed this into A equals P e to the RT when we did continuous compounding. But the point being, there's nothing new there. Okay, on 625, I'm just trying to carry through the discussion here so you can realize that what we did before and what we're doing now, very similar. Here's your APR, annual percentage rate. And note that, as we come off there, that I have today extended that to an EAR, effective annual rate. And there is a nice statement for compound interest. And it says, compound interest is calculated based on principal and prior earned interest. Prior earned interest. Sort of an interesting phrase. I've just said you add the interest onto your balance and leave it there. And then recalculate the interest and just never take that amount out. It's interesting for me to look at Math 10 this year, this semester, and then working with you in 20 after you've had the Math 10, and the things that they're having trouble understanding sometimes is that after all the work we did in a payoff table with a credit card, that you don't subtract anything when you do compound interest. And I just gave a test in the Math 10 this morning, an hour before you came in, and one of the questions that one of the students had, do I have to subtract with a compound interest table? I feel like I'm not doing what I should. And of course the answer was, no, you're not going to take any money out, you leave it in the bank. So all you keep doing is adding. Well, that's, of course, what that 1 plus RT was all about. So the effect of this is in a problem that is shown on page 626, and I'm hoping, by the way, in this process, that as you read through here, this is like your second go with this, that maybe some things will get clarified for you. Because if I'm going to do the compound interest every time, it has to do with what we did in the board, Ernie, as I go back to camera 2, where I take something to a power. So as we come back over here, when I talked about this compound interest, this is your 1 plus r t, and t was 1 over 365. That was 1 day. So you did the amount of money that we had up here. This is your 1 plus rt, and then you did it for every day. So if you did it for a full year, it was 365. If you did it for 30 over 365, then that meant this was just 30. Well, trying to get the understanding that you're going to multiply by 1 plus rt times 1 plus rt, and then go to the y to the x key, is what I worked very hard in that unit in Math 10 to accomplish. As we come back to the center here, and unfortunately I have the camera screwed up, but if we look at what's done on page 626, here's that same argument where this was, I believe, an 8% interest rate done quarterly. So your 0.08 divided by 4 becomes your 2%. There's your 1 plus 0.02, and you just kept multiplying by this. So for the year, this is your y to the x, and you do 4 for the x. This is the y number is going to be 1.02 to the 4th power, and then that gives you the balance at the end. Okay, so again, that's just explaining where we've been before. There's a semi-annual problem, but what I'd like to get you to understand, what we just talked about, this is your formula that we've been using, and this is what we did as y to the x. And interestingly, I just asked this question on the test. This is your y value, where I have the pen. This is your x value. And I said, what do you use for y? What do you use for x? And they had to answer that question on the exam just an hour ago. Well, that's the idea of the formula. And then what happens as you do continuous compounding? Remember, for daily, this is a 365 where I'm pointing to the end. And then you have 365 by the number of years. But what if I do it instead of 365 every day, I do it by hours? Then this becomes 365 times 24. And then change up here. And then I do it by minute. And then by second. Okay, and so this denominator gets smaller, or gets bigger, so that portion gets smaller. And so what we end up in getting is E. 1 plus 1 over x. As x goes very, very large, all to the x power just becomes E. So if I take, I don't know if I can illustrate this very easily for you, but this is a point where we talked about this, and Ernie, give me a moment. I've got to try to get this camera and glare to work for me, and I'm not real pleased. But here's what I'm going to do. I'm going to try taking 1 point, okay, tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, 10 millionths, 100 millionths, billionths. Y to the x to the 1. Okay, so there's my 1,000, million, billion. Okay, I can't see what I have there, and it's not cooperating. Okay, coming off there, Ernie, I'm going to try that. I exceeded the calculator's ability to do anything. So I'm going to try 1.001 y to the x and try 1,000, and then equals, okay. And notice I'm getting 2.71. Now that was 1.001 to the 1,000. So I'm going to again take 1.000. I'm going to try going to the millions. Tens, thousands, hundreds, thousands, 10 thousands, 100 thousands. There we go. and I want a 1. Do I have enough zeros there for what I want? Come off there for a moment, Ernie, so I can move the camera so I can see. Tenths, hundredths, thousands, 10,000s, 100,000s, millions. I went one too many place. So I want 10 million. So I'm going to hit y to the x and try 10 million. 1, 2, 3, 1, 2, 3 equals, yes. And I get 2.71828, and remember that was e to the x nearly. That's the argument. That's where e came from. A problem in finances with going back into the 17 and 1800s. So that's what we see down here in this formula. So again, the argument with this formula, that as we go back to the document cam, that as n gets very, very large, this becomes 1 plus something very small to something very large, and that just becomes e. Now, if I have 1 over n, it would just become e. If it's r over n, it becomes e to the r t. So with that said, coming off there, all that you're doing here is using that formula until you come down to problems like this in page 628. And I think you may need a calculator as you try these problems. But this is a case where you have $685.72 in the bank. You're doing it daily. That's why the 365, you have a 14.9%. And this, in essence, would be the interest you would pay plus the original. There is your balance on a credit card with what we talked about 15 minutes ago. So you had this is your bill, compound interest for your credit card, and so you would owe $694.17 as opposed to what we were doing before. And that's illustrating how you do the credit card. Now, on page 628 for your interest, and again, it's punning like this throughout this part because it is about interest, but of interest on interest. Here are the two methods, and this is the process we used in our class where we just divided by 12, and then we have another one here where you're doing it by 365 and then doing it with simple interest. Just two techniques are talked about here for credit cards. That is what got me wondering what else can be done, and that's where I went to Google, and then I ended up with that Wikipedia entry that I thought did a very nice job of explaining it. Now, there's another part to this that we've not done before, and it relates to how do you make sure you pay off a loan in the appropriate time frame. So you buy a car, and in 5 years you want it paid off. You buy a house, in 30 years you want it paid off. You charge a credit card in Christmas, you want it paid off by next Christmas. So you can start over again. Create your own liquidity. We call it an amortization table. Okay, and to amortize, here's the verb, to pay off a loan or debt in installments. So you amortize a loan to pay it off. And so an amortization schedule is set up so you pay it off in a fixed number of years, and we have a table, and this reminds me of what bankers used before computers. Roughly even before, well, the banks were using mainframes in about 1966 to 68. They started using mainframes. This means the computer would have taken a room this size with all its peripheral equipment, and I'm serious. That's how large a room they would need. Just, well, to keep track of your balance, to keep track of your checks. And B of A, for example, started instituting the computer then, and I really got frustrated with them because of their philosophy. If there was an error, their standard response was, we don't make mistakes now, the computer's doing it. And of course the reality is that the programmers sometimes would screw up and errors got made more quickly than ever before. It was hard to convince the banks of that back in the late 60s, early 70s. And then of course now you have the power of those mainframes on a desktop many times. And we see the advertisements of IBM where they replace an entire room of computers with one blade server, as they call it. And the power of that is amazing. Well, these tables that you see on page 630 are still available, I suspect, at garage sales and such place where you can find a table that will tell you how much you pay to get something paid off in a fixed amount of time. And there are formulas we can use. And that's what I want to come back and look at tomorrow. Just a little more detail. But I thought it was interesting because of what I can show you here. Here's your 5-year payoff. And this is for the car loans that most of you were getting before you quit buying cars. Okay, so this is the frustration of the automotive industry. People are not rushing out to buy the latest model. But let's say that you went out and down here, just near the bottom, I have a $20,000 vehicle. And of course, many of these times they just said, what? $20,000, no down payment, just show up, smile pretty, and we'll let you pay it off. And by the way, the interest rate for this table is at 9%, which was considered pretty steep. So you would pay $415.17 for each month for 5 years to drive out and drive that $20,000 car. And of course, at the end of the 5 years, as we come off there, how much would you have paid totally for that vehicle? Okay, well, too much is not the answer I want. I'd like more than that. You've got a calculator. So let's come back to that number. You have $415. So I need to come down to where I have that figure at $20,000. So you take that 415.17, multiply it by 60. And what figure do you get? Okay, give me the number, James. 2491.20. So you basically are paying $24,910. That car cost you, in addition to the $20,000 you financed, $4,900, nearly $5,000. Okay, so that's what you paid. Yeah, you haven't paid the registration, you haven't paid the sales tax, and the what? Oh yeah, you have the insurance you pay. You have to pay the preparation. Well, maintenance? No. You're only going to drive it 5 years. Trade it back in. So why change the oil? Now, okay. I know some people who don't do anything in those 5 years. But by the way, what is it worth 5 years later? You paid $24,900, and you might, well, let's say 18 months ago. 18 months ago, you might have managed to get what out of it? Half, if you're lucky. Now, I have a friend who had a BMW that was, I think they paid $30,000 for it, and they were trying to get their half and couldn't sell it recently, and it only had 30,000 miles on it. Yeah, but nonetheless, nobody was interested at 50%. I think it was worth 35 originally. They were going for 17. Figured, okay, we'll cut it in half. And they couldn't sell it. Even at, pardon? Well, what do you define as old? 1960, 1940. I mean, I've got this great 1938 Chevy, right? And you'll only pay $30,000 for it. Tongue-in-cheek, because it becomes old and becomes a classic and therefore worth more. But the point is, you paid $5,000 more, and at best you might get 10 out of it. So in that period of time, your total cost was 25. You got 10. It cost you $15,000 for 5 years at $3,000 a year. So some people prefer to lease. Some people prefer to ride bikes or go on the bus. So amortization schedules. Now let's take one more because it's the fun one. Okay, this is all part of the process if you're going to be doing truth in lending, because they're supposed to tell you what your total cost is. Okay, let's go house shopping. $200,000. And by the way, $200,000 at 9%, you're in deep trouble. Okay, but there's your $200,000. It's 3 lines from the bottom, and 30-year loan. I'm over at the far right, and this means that you are paying on that $200,000 house $1,609.25. Okay, well, you multiply that times 12, and then multiply that by 30, and this is where we'll end up in this somber note on the house, which now will be worth $100,000 because of foreclosures. Okay, so we have 579,330. Okay, so that means, and what are the pennies out here? Oh, well, good. So that house is running you $579,330. You only paid $200,000 for it, so it's run you $379,000 to buy it above the purchase price. And by the way, in foreclosure, it's worth $100,000. Okay, so in essence, the foreclosure, it's worth $100,000, so you've lost $479,000, nearly $500,000 in the process. That, my friends, is called the economic meltdown that we are in. So on that depressing note, we'll come back and try to put Humpty Dumpty together again tomorrow using some formulas. Have a great day. Oh, by the way, Ernie, what are we playing for music? Every breath you take.